Hello everyone, I hope you all are doing well. So now we will be continuing more further with the chapter conic sections, and we'll start with the shape of geometry today with ellipse. We've already studied what parabola is, how are its standard forms, how can we write its parametric equation. Now we will be looking into ellipse. Ellipse is not very much different from parabola. However, the major terminologies that we had studied in the introduction chapter are same. So without further ado, let's look into it. So first we will be looking into a brief introduction. We will be revising all the terminologies and the concepts of the shape of ellipse and how it works. Then we'll be looking into the standard forms and the parametric forms of ellipse. Then we will look at different chords, position of point. Along with this, we will be studying position of line and other conics. And then we will look at a new property of ellipse, which is the reflection property. Earlier, as I had also mentioned this in parabola as well, that there used to be topics such as tangent, normal as well. However, those has been removed from JEE Mains syllabus this year. So let's start. First of all, what is an ellipse? It is a locus of a point that moves such that sum of its distances from the two focuses is always constant. If you remember, I had told you in the introductory lecture series that ellipse and hyperbola are two conic sections which have two focuses, and its eccentricity lies from 0 to 1. For parabola it was 1, here for ellipse it lies from 0 to 1. This is somewhat our ellipse, how our ellipse looks like. This is what we call as the major axis. Here there is one focus, F1. Here there is another focus, F2. This one, the shorter one, is what we call as the minor axis. And let us take any point P, x comma y on this ellipse. Now the distance of Px2 and Pf1 would always remain constant. That means Pf2 plus Pf1 is equal to constant, always. This is what is the definition of ellipse. Now what is this constant? Let us try to find that out. This is our ellipse. So this is the minor axis, this is the major axis, this is our ellipse. This length here we refer to as A, and this length here we refer to as B. So this length is A, that means this entire length inside the ellipse is 2A basically. So this constant here is nothing but 2A. And also, if you remember, we had studied in the introductory lecture that there is also two directrices when it comes to ellipse. This is our directrix. And if I take any point P and there's F, and if I drop a perpendicular here on the directrix and name this point as M, and I join this line, then eccentricity is equal to PF by PM. And since this is an ellipse, we know since E is from 0 to 1, that means PF will always be less than PM. So this is a thing. Now let us revise a few more other concepts of ellipse. This is our major axis, this is our minor axis. Now again, ellipse can be of two forms. It can be vertical as well. This is the horizontal ellipse that we are talking about. Horizontal ellipse. This is what we call as the major axis. This is what we call as the minor axis. This is our center. Here is our focus F1. Here is our focus F2. The first directrix, the second directrix. The second directrix. And now we know that this length is represented as A. This is also A, and this length is B. Similarly, this one is also B. So this is an important thing to remember. Now there can be chords in this ellipse as well. if any line intersects the ellipse at two different points, then we call it a chord. And now let us say if this is an ellipse, and if the chord passes through the focus, then we call this a focal chord. And if that focal chord is perpendicular to the major axis, let's say this is our minor axis, our F, let's say a chord is perpendicular to the major axis, then we call this as the double ordinate. The definitions of these terminologies are same as that we had studied in parabola. And now if this double ordinate passes through the focus, then it becomes our latus rectum. So if this is our ellipse, this is our focus, a chord passes like this, which is 90 degree to the major axis, then we call this as latus rectum. Now one more important concept to remember here, since we know this is A, this is B, the thing to remember here is that E is always represented as E square is represented as 1 minus B square by A square. You have to keep in mind that B is the minimum value here and A is the maximum value here. Now let's say we were given a vertical ellipse in this format, then we know that this length here, B, is greater. Then at that time E square would have become, E square is equals to 1 minus A square by B square. So the value which is small is kept at the numerator form and the value which is large is kept at the denominator. So this is how E square is calculated. Important formula you must remember. One more thing that you need to remember, there is another thing, A square minus B square. We refer to this as C square. Now this is just a notation that you need to remember, A square minus B square is equals to C square, because sometimes you might see that in questions E square is given as C square by A square. So you have to understand that C square here is nothing but A square minus B square. Now let me give you one more important point about an ellipse. Let's say if this was a standard ellipse and this is our point 0, 0. So this would become A, 0, and our directrix would lie at x is equal to A by E. I hope you all understand that E is less than 1. That means if I am writing A by E, then it is a value which is greater than A. And here x would be minus A by E. This one would be minus A, 0. And the focuses, the coordinate of focuses is written as F1 is written as AE, 0, and F2 is written as minus AE, 0. Now again, these are important things. These are for standard ellipses that we will be studying when we study the topic standard forms of ellipse. This is just for you to understand how these terminologies, which is eccentricity A and B, work with an ellipse. Now we'll start with the standard forms.